Good morning. This is R. Kalpana from Tech Multitech Dr.Rangarajan Dr.Sakunthala Engineering College, Assistant Professor, ACE Department. Today I am going to take about what are the basic elements of optical fiber link. Generally, communication means exchanging information. So, communication means we are going to transmit information from source to destination. Here, in optical communication, we are going to transmit your information in the form of lights. See here, what do you mean by optical fiber? So, it is a dielectric waveguides that operate at optical frequencies, which confines electromagnetic energy in the form of lights and guides the light in direction parallel to its axis. So the propagation of lights from one place to another place that can be described a set of electromagnetic waves called that electromagnetic waves we can call it as modes of the waveguide. So we can classify it into guided modes and unguided modes. Each mode in a pattern of electric or magnetic field distribution that is repeated along the fiber at regular intervals. So optical fiber, it consists of core and cladding. These are the major components. So this is actually a diagram of optical fiber which consists of core, cladding, buffer and outer jacket. So core is a glass. It is made up of glass or plastic with higher refractive index than cladding. It carries your optical signal. Cladding is, it is also made up of glass or plastic with a lower refractive index compared to the core. The buffer, which will protect the fiber from damage from external noise and moisture. Jacket, which hold one or more fibers in a cable. In a cable, we are having more number of fibers which will be covered by a jacket. Here we can classify the light traveling path, we can call it as modes. We can classify in different paths, that is single mode fiber has a core diameter of 8 to 9 microns which only allows one light path, and the light traveling path we can call it as mode. Multimode step index fiber. So here the multimode fiber has core diameter of 50 to 62.5 microns, sometimes even a large value more than 62.5, which will allow several light paths or modes from one part of the fiber to another part. This will cause a dispersion, which is one form of loss, and some modes are take longer to pass through the fiber than other because they travel in the longer distance. Multimode graded index fiber, the index of diffraction gradually changes across the core. So it will varies. So the modes travel further also move faster. This reduces modal dispersion. So the bandwidth is greatly increased. So this is the comparison of fiber structure. Here we are having that is the fiber cross section and the ray path. So the light traveling path we can call it as modes. If the only one light process means that we can call it as single mode, or single R we can call it as monomode step index fiber. Mono means singles. So here core having higher refractive index than cladding, and only one light will passes through along your core. So here the core diameter of 8 to 12 micrometer and cladding of 125 micrometer. Similarly, for multiport step index fiber, more than one light travels along your core, and here the core diameter of 50 to 200 micrometer and the cladding will be 125 to 400 micrometer. And multimode graded index fiber, here the refractive index gradually changes along the core, and the core diameter of 50 to 100 micrometer and cladding will be 125 to 140 micrometer. So the advantage of optical fiber communication, so these are the main advantage, very high bandwidth. So here the bandwidth will be 10 to 500 gigahertz and the attenuation will be low. It is about 0.16 decibel per kilometer. It will be immune to electromagnetic interference and the security will be high, data security, almost impossible to trap the information. Secured information we can transmit via your optical communication. Lower system cost, fewer repeaters due to low attenuation fiber, small size and low weight, and very low bit rate, less than 10 power 10 typically. The basic of optical fiber communication. So here we are having three major parts: transmitter, optical fiber and receiver. Here in the transmitter part, the very important component is optical source. Here generally the naturally available signals are electrical signals, and here in optical communication we are going to convert your electrical signal into a light signal by means of optical source. Here majorly we can use LED and laser diode, and with the help of driver circuit we can transmit your light signal from one part to another part. An optical fiber, it may be a single mode fiber or a multi-mode fiber. In the receiver part, and here again the light signal will be converted to electrical signal by means of a photodetector, generally twin photodetector and avalanche photodetector. So these are the major component of an optical fiber link. So generally communication we are going to transmit electrical signal. Here in optical communication, here you are going to transmit your information in the form of light. So the input signal will be electrical signal that is first given to a transmitter circuit. Here the transmitter consists of drive circuit, light source and fiber fly lead. And the here in the dark line will be represented by the signals are transmitted in the form of electrical signal. Here in the shaded lines, here the signals are transmitted in the form of light signals. And the connector, optical splice and optical fiber and optical coupler, which will be combined mode light signals, or we can call it as beam splitter. We can split the signal, light signal from one fiber to another part to other equipment, and consist of regenerator. Here for long communication we are using a regenerator. So at equal intervals of time we are going to place on regenerator, which will compensate the any loss will be occur during the transmission. And here the regenerator, the main component will be optical receiver, and here the optical receiver we can receive the signal, again you can convert into the form of electronics, and again the optical transmitter, like the electrical signal will be converted to light signal and will be passes via your optical fiber, and it consists of optical amplifier, and finally to the receiver circuit where the light signal again will be converted to electrical signal with the help of photodetector and a signal restorer circuit. Here, the optical fiber transmission link consists of several key elements. First, the transmitter, light source. The transmitter uses a light source such as laser diode or light emitting diode to generate optical signal. That is, generally available signals are electrical in nature, which will be converted into the form of optical signal, which convert your electrical signal into a light pulses that will be transmitted through the optical fiber. The light source in optical fiber system generate optical signal for a data transmission. The common light sources are LED and laser diodes. So here LEDs are cost effective and used for short distance communication, while laser diodes are high power, narrow beam and faster speeds for long distance. So depends upon our need. For short distance means we are going to use LED source. For longer distance means we are going to use laser diode. And high speed communication. The light source must match the fiber port size and operate at specific wavelength. So example, it may be 850 nanometer or 1310 nanometer or 1550 nanometer for minimal loss. It is controlled by a driver circuit for stable operation and modulation. So the drive circuit. So in the transmitter we are having the thing that after the light source we are having a drive circuit. So it is in the optical system which controls the light source from the laser diode or LED to convert the electrical signal into optical signal. It provides bias current. The very important thing in the drive circuit is a bias current for steady operation of modulation to encode the data onto the light. So the key components includes bias control circuit and modulation driver and a feedback mechanism to ensure the stable output and protect against current overloading. The circuit must handle high speed, minimize the noise, jitter also a time delay. It is also one type of noise. We have to minimize the thing, and that should be done by in the driver circuit, and compensate the temperature variation. It should be used in the telecommunication, data center, optical sensor. Efficient design ensure reliable high-speed optical communication. Then fiber fly lead. So actually it is a patch cord. It is a short or flexible optical fiber cable with connectors on both ends used to connect optical waveguides or links to or link network component. It is typically consists of fiber strand, a single mode or multi-mode enclosed in protective sheathing. Fly leads come to various connector types. They ensure minimum insertion loss, back reflection, critical for signal integrity. Fly leads are used to telecommunication data center and testing center. So their length, connector type, policing type. So we are having there is two major types: APC, angled physical contact, or UPC, ultra physical contact, depends upon the application. Fiber optical connector. It is a joints of two optical fibers. So for long distance communication, we are not using a single optical fiber. Here we are going to use a connector to connect two optical fibers in an optical device, ensuring this precise alignment, efficient light transmission, and the light travels along your core. So which includes different types device compatibility. Connectors are caused by APC or UPC. They minimize insertion loss, back reflection, critical signal integrity, and the component that is ferrite holds a fiber and housing and boosts the strain relief. Connectors are widely used in telecom, data center, and testing setup. Proper cleaning and maintenance of crucial and optical performance. The optical splice, it is a permanent joint. So the difference between connector and splice is a permanent joint between two optical fibers, ensuring low loss and reliable light transmission. It is used to extend fiber length or repair broken cables. There are two major types of fusion splicing, which fuses fiber using heat, and mechanical splicing, which aligns fiber in a mechanical fixture. And fusion splicing offers low loss, typically less than 0.1 decibel, better durability, while mechanical splicing is faster and easier for temporary or low-cost solution. It requires precious equipment and careful preparation to ensure minimal signal and reflection. Optical fiber. So we are having a core, the core having higher refractive index than cladding. So it is made up of glass or fiber. The core is a central region of optical fiber through which a light transmitted, that is made up of glass or plastic, higher refractive index than cladding. Cladding surrounded by a core. Cladding has lower refractive index than core. It helps to guide the light within the core by reflecting it through total internal reflection. Coating. A protective coating surrounds the cladding to provide mechanical protection and prevent damage to the fiber. Buffer. An additional layer called buffer may be added further protection. It absorbs shocks and provides additional protection against environmental factors. An optical coupler is a device that split or combine optical signal in fiber optic system. It distributes light from one fiber into multiple fiber or merges signal from multiple fiber into one. We are having common types 1 cross 2 and 2 cross 2 splitters and waveguide dependent couplers. So optical couplers are made using fused biconic fiber or planar light wave circuit technologies. Key parameters are insertion loss, splitting radio, and wavelength range. They are widely used in telecom, fiber sensor, and passive optical network. Couplers ensure efficient signal routing with minimum power loss. A regenerator is an optical fiber system restores a degraded signal over long distance. It performs optical to electrical conversion and reshaping and electrical to optical conversion to improve signal quality. 2-hour generators reamplify reshape signal while 3-hour regenerators are retime then synchronization. These devices are used in older systems where signal loss and noise occur before reaching the destination. They are placed at specific intervals along the fiber link. Modern networks often use optical amplifier as a more efficient alternative. Regenerators ensure reliable long-haul communication system. An optical receiver, so after transmitting it reaches the receiver, is a device that converts optical signal transmitted through the optical fiber into electrical signal. It is typically consists of photodetector like photodiode, which absorbs incoming light and converts into a photocurrent. This current is then amplified and processed to retrieve the transmitted data. The receiver also receives amplifiers to boost weak signal and signal processing circuit to handle errors and noise. So key performance parameters include sensitivity, response time, and dynamic range. Optical receivers are crucial in systems like telecommunication, data center, and fiber optic sensor. They ensure the accurate detection and transmitted data. The receiver, it consists of photodetector. The receiver uses the photodetector such as photodiode to convert the incoming optical signal back into electrical signal. The photodetector generates an electrical current in response to intensity of received signal. Amplifier, which will optical amplifier may be used to boost the strength of the optical signal during transmission to overcome losses and ensure reliable signal. Demodulator generally we can recover the signal. Here the demodulation, the modulator that is the light signal again converted into an electrical signal. So the demodulator is used at the receiver to extract original information from the optical signal. So optical amplifier generally we can use erbium doped fiber amplifier, mostly used optical fiber amplifier can be used to amplify optical signal without converting into an electrical signal first. This helps to extending the reach of optical transmission. So the light signal which will be transmitted via the core by the concept of total internal reflection. So in optical communication, this is a very important topic, total internal reflection. So it is a fascinating optical phenomenon that occurs when light wave traveling through the medium hits the boundary of lens, dense medium and reflect entirely back to the original medium. So here this happens under specific condition related to angle of incidence and angle of refractive indexes of two media. So this is a total internal reflection concept. So here we are having two medium having different refractive index, refractive index N1 and refractive index N2. So here in our optical system, the core having refractive index N1 and cladding having a refractive index N2. Core having higher refractive index than cladding. So N1 is greater than N2. So when the light will be travels from one medium to another medium, so here the refraction will be occurred. Here see here when light will be traveling means it will passes along the same medium. So it will be reflected, part of the signals will be reflected back and part of the signals will be refracted that will pass us through the another medium that is N2 here. So here the total internal reflection in the sense all the lights will be transmitted here the back to the medium. So that is known as the total internal reflection. The refractive index, total internal reflection occurs when light travels from medium with a higher refractive index to a medium where the lower refractive index. Here the critical angle, there is a specific angle of incidence called critical angle. Here by using a Snell's law concept, the critical angle at which the light ray traveling from denser to rarer medium refract along the boundary. If the angle of incidence exceeds the critical angle, the total internal reflection will occur. So critical angle theta c can be calculated using Snell's law. So sin theta c equal to n2 by n1 and n2 and n1 are two different refractive indexes, that is core and cladding. So the application of total internal reflection. So in optical fibers, the total internal reflection is a fundamental principle behind the optical fiber. Light signals are transmitted through the fiber core by repeated total internal reflection, allowing for long distance and high speed data transmission within minimum loss. So here binoculars and periscope, many optical devices are uses prism designed to cause total internal reflection, improving image quality by reducing light loss. So diamond brilliance, the sparkle of diamonds is due to total internal reflection. Light entering a diamond undergoes the multiple total internal reflection, enhancing its brilliance and fire. So here, that's all about your the basic elements of optical fiber communication and important concept, total internal reflection. Thank you.